Tell me when you're ready. Good. Yes. No, Ranjit, maybe you can turn your camera towards the screen so I can see what, instead of looking at the audience, I can look at the screen, yeah. And put my presentation. Yeah, I see it now. Yeah, I see. Well, it's on the side. I can see I see the other screen. I see the. All right, good. I can see. All right. Good.
Hello. Good. Hello, everyone. Sorry for the delay, but so we had some technical difficulties in setting up the projectors. But today we'll start with Professor Nicholas Themelis' presentation about mostly speaking about how waste to energy can be put in a perspective for India's short and medium term solutions, and he'll also speak about the hierarchy of solid waste management and how recycling and composting also play a major role in that. And Professor Nicholas Themelis is the director of Earth Engineering Center, Columbia University, and he was the person who changed Henry Krum's School of Mines in Columbia University into the Earth and Environmental Engineering Department, which is now. And he's been very active in the waste management research, and he's very world-renowned expert on waste to energy. So with this, I'll ask him to start the presentation. And
Thank you very much, Ranjit. Good morning, ladies and gentlemen. I appreciate you coming so early in the day to listen to this talk through the web. I wish I were there in present. I was there in present, but it was not possible, so this is the best I can do. I have taken the liberty to change slightly the title of my talk to what international experience has taught us about managing the urban solid waste. Being a developing country like India has some disadvantages, but also has some advantages, because they can learn from the lessons and the mistakes of the so-called developed countries. So in this lecture, I will try to put forth what we have learned, and we have studied this extensively in the last close to 15 years, by looking at the most advanced countries with regard to sustainable waste management. This is going to be the topic of my talk. The first slide gives in a picture is worth 1,000 words, they say, what we call the hierarchy of waste management. And the top is waste reduction, to try to have as little waste as possible. India has no problem with that because they are not producing that much waste. And it's a good thing for India and for the world. If they were producing as much waste per person as the United States, they would be producing what is now the total global generation of solid waste. So that's no problem for India. The next is down the line, down this pyramid, let's say, of hierarchy, recycling. To recycle materials. And then further down, we have now anaerobic composting and aerobic. One of them, anaerobic, is higher because it generates some heat, some energy. But as we will hear later on, it's much more costly, more difficult to do than aerobic composting. And after you've done those three things, recycling, anaerobic, and aerobic composting, you come to waste to energy. This is now the recovery of energy and metals from solid waste. And below that, you see three classes of landfills. The modern landfill, sanitary landfill, we call it, that recovers and uses methane. Sanitary landfill that recovers but flares the methane, does not use it to generate electricity. And at the bottom, we have the traditional landfill, which unfortunately is prevalent still throughout the world. So these are the ways that we can handle urban waste. You can see that from a sanitary landfill, and actually I see this 125 kilowatt H should belong to a bit higher up. It didn't come correct on the slide. It's a landfill that recovers and uses CH4. The maximum you can produce is 125 kilowatt hours of electricity, while waste to energy is 600 kilowatt hours, and you can also generate some electricity from anaerobic digestion. Next slide. Let's talk about recycling. What have we learned about recycling from developed countries that we can apply to developing ones, like India? The least costly way for municipal government to increase recycling is to ask citizens to separate their solid waste to two kinds. One would be designated recyclables. Those materials that the municipality knows can be sold, that the market will use. So that's one. And the second, everything else to go to a different bag or bin or container, trash. And that trash now can either be landfilled or sent to waste to energy plants. So coming back to the recycling then, first is to tell people to separate the two things. That should be relatively easy to do, but of course needs information, dissemination of information, and for people to use two bags instead of one or two bins and so on. Then, in a country like India, it would be good for the government, the municipal government, to encourage the informal recycling sector. India, we call them scavengers or whatever name you want, people who go around and pick the recyclables. You see, the idea is that if the citizens have put the recyclables into two streams, separated them, each citizen, then it's a much pleasant and easier job for the scavengers to collect. Otherwise, what the scavengers do, they get mixed waste, they pick a few things that they can sell, and the rest, they may discard it any place, or then, worse than that, they may set fire to it, which is the worst possible thing that can happen to solid waste. So, by separating two recyclables, let's call them dry, the dry stream, we make it easier for scavengers. There can be other ways to encourage scavengers, maybe to provide uniforms, to provide some rudimentary means of transport. But any recyclables that are not collected by the scavengers must be collected then by the city. And of course the city knows or should know how to market these materials. That's why they were designated as recyclables. They usually go to a materials recovery facility where, with a minimum amount of mechanical equipment and with a lot of people, you separate them now into marketable streams. Paper, some plastics, metals of different kinds. So that's how recycling can be done, and it will not cost too much. More costly ways would be mechanical separation and so on. We don't need to discuss this because labor is not costly in India. You can have people to separate the materials to recyclables at the MRFs, at the recycling recovery facilities. So let's move now to the next, composting. How can you increase composting? Well, what we have found, and everything I'm saying here is based on the experience in developed countries. The least costly way of composting is what we may call aerobic composting, using air which naturally moves through a windrow, a pile of waste, of organic waste. So the municipal government, in order to increase composting, needs to provide a windrow composting center, someplace where municipality and citizens transport their park yard waste. Now here in India, cities would be mostly municipality waste, park waste, tree waste, grass clippings, and any citizen who has a yard, he puts his green waste in a bag and brings them to this center. And from this center then they take back, if they like to, the compost product of the center. It's a very inexpensive way to do composting of green yard waste, but not of food waste, because food waste, if you mix them up there, they would smell. So there's different ways that you can do food waste. I won't talk about that today. So the next and more costly means for composting is what's called anaerobic digestion. There you need equipment, mechanical equipment, and people and electricity to run the equipment. And there, to start with, you can start with source-separated food waste from large generators. It's difficult to ask people to separate food waste in a separate kind of a thing because it's more difficult. It has been found to be difficult and more difficult to collect and so on. But if there are large generators, institutions where a lot of food waste is produced, or food processors, they can go to an anaerobic digestion and they can produce methane and compost product. Incidentally, India was one of the first countries to use anaerobic digestion for agricultural waste. They still use it to a large extent. So it can be a combination of urban waste and agricultural waste or industrial food processing waste that go to an anaerobic digestion plant. But that plant is not going to be cheap. It's costly, but you recover energy and you recover a compost product which can be used as a soil conditioner. Next slide, please. Okay, now let's say we have done recycling, we've done composting as much as we can. What can we do with post-recycling waste? There cannot be zero waste as some people think and hope for. There always will be post-recycling waste. So there are only two proven alternatives to waste dumping for India and for other countries. Waste dumping is what, indiscriminately or in some lot, people throw their waste. This is the worst that can happen. And to that, there are only two alternatives. One is a sanitary landfill. A sanitary landfill protects the ground and surface waters and reduces greenhouse gas emissions by an estimated 0.5 ton of greenhouse gases per ton of solid waste. I'm saying this because soon there will be a price to carbon emission. So if a process that reduces carbon emission would have a revenue. Already in some places there is a revenue for sanitary landfills. Now, a sanitary landfill is not cheap. it costs $100 to $200 per annual ton of capacity to build, and uses 1 square meter of land for every 10 tons of solid waste. So we're moving away. There has to be a payment for it. The next and the only other alternative is, let's call it gasification combustion. It's a combination of gasification combustion with energy recovery. We call this also waste to energy, and you have the Waste to Energy Research and Technology Council of India that's sponsoring this event. Now, the dominant process, the one that's used for 85% of the so-called energy recovery process, is combustion on a moving grate. It's a costly process, more costly than landfilling. It costs 300 to 600 per ton of annual capacity. By the way, the range I give there, 100 to 200 and 300 to 600, is because of the labor costs for building those plants. I would expect in India to be about $300 per ton of annual capacity, and I would expect sanitary landfilling to be 100 tons. But anyway, if you build this process, if you build such a plant, you have to invest money at the very beginning of its life. Its life can be 30 years or more. We have plants in the world have run for 60 to 70 years. But anyway, you have to spend $300 per ton, but you have the electricity revenue now, which is $60 per ton at $100 per megawatt hour, which is what I expect to be the price in India and in other developing countries. So you spend more money, but you have a source of revenue. But of course, to do that, it's like planning for a long-range, long-term operation. If you want to do the quick thing, of course, you dump. The next costly thing is the sanitary landfilling. And the more costly, but in the long run, more economic means is waste to energy. Now, in the next slide, I'm sorry, I just discovered this tonight, that when I transcribed this slide, the program cut out every second name. So you have there, you can see that you have 25 nations, but overall there should be 50 nations. If you want for the United States, for instance, would be under the EU. And what we have here is this. On the left, on the x-axis, we have the countries that we have included in this graph, and on the y-axis, and on the x-axis, we have the percent of solid waste treatment. In other words, if you treat 20% by recycling and composting, we add those two, you would be on the left side of this diagram, the green line. For instance, if you look at the European Union, you have about 40% recycling and composting. The average of the European Union, of all the 27 countries, is about 41%. And then on the right end of the graph, we have the waste to energy percentage. And you can see that some countries, for instance, Japan has 75% of its solid waste go to waste to energy. The European Union, you can see that if you look at the 27 countries, you have about 18% average. But there are two important things about this graph. One is that if you want to reduce or eliminate landfilling, the only way you can do it is by a combination of the greens and the reds. Recycling and composting on the left, waste to energy on the right. The second important thing is that there are nations, a number of nations. You can see there 8 mentioned, but there are more because, like I said, some of the lines are not named. They already have done it. They have been able to eliminate land. And they've done this by a combination of recycling, composting on one end, and waste to energy on the other. We call this graph the ladder because it looks like a ladder. As you go up, the higher up you are, the more sustainable waste management you have. Now, this table has a lot of numbers there, but what it shows is countries where our organization, WTIT, or the Global WTIT Council, has worked. Yes. Which one? I'm sorry. Okay, back to the ladder. What did you hear on the ladder? Okay. So the ladder is shown here, and again, to eliminate or to reduce land filling, you need a combination of recycling, composting on one end, and waste to energy on the other. Next slide. Ranjit, don't hesitate to interrupt me if there is any connection problem, all right? Okay. Now, this table shows countries that in the last 10 years, one or the other way, we have worked, we have dealt with. They either have waste to energy plants or they have sanitary landfilling and so on. But these countries that we have here, all of them have one or more, the ones in the red, I'm sorry, the ones in the red color, they have one or more waste to energy plants. And here we show them in the order of gross domestic product per capita. The gross domestic product I'm speaking of is the purchasing power parity, not the real dollars, but what the dollars can buy in each country. And you can see some countries very high up, Qatar, you can see Bermuda, Singapore. Now Qatar is putting a waste to energy plant, Bermuda has a waste to energy plant, Singapore, and so on. And then you go down the line and the gross domestic product decreases. And India is, of course, below end there. So the next slide, okay, in the next slide, we've done something else, and I'm showing this to you for the first time. Not even Ranjit has seen that. We call it the matrix of sustainable waste management. Here, what do we have? On the left axis, on the y-axis, the left axis, the y-axis, we have the position of each country on the ladder. Remember the ladder I showed you? Where does it stand on the ladder? In relation, and in order to use a reference there, we used the European Union. So, we divide the rating, the environmental management, waste management rating of each country by the rating of the European Union. And so you can see that the European Union is 100%. There are some countries who are below, no, it's not 100%, it's about 70% level. There are countries who are above it, Taiwan and Korea, and countries are below. Now, what do we have on the x-axis? On the x-axis, we have the gross domestic product, and again, we have this expressed as a ratio of the gross domestic product of a nation divided by the European Union gross domestic product. In other words, this graph places nations in relation to the European Union. The European Union comes there at the middle. You see the circle at the very middle where the two axes meet. I cannot point here, but you can see. That's the European Union. And what do we have here? We have four quadrants. We have countries which have a low GDP, but a very high sustainable waste management rating. Korea and Taiwan. It's interesting. The GDP is not very high, but from an environmental point, they're very high up. Because they wanted to be, I guess. They decided somehow. Then, on the left lower quarter, we have countries with low GDP and low waste management, which you can understand. If you have less money, you're not going to take care of things, as environmental things, as you could. Thank you very much for that. That's very good, Ricardo. Okay, and now going down to the right lower quarter, we have high GDP, a lot of money, but low solid waste management rating. And regrettably, the United States is in that quarter. And other countries like Australia and Canada, high GDP, but they are not doing enough for sustainable waste management. You know, they landfill too much, let's put it this way. And then at the very right quarter, the top right quarter, you have countries, high GDP and high solid waste management. They really are doing very well. And you can see the countries there. There would be Austria, it would be a lot of the European countries, some of the European countries, the northern, Japan, and so on. So this is the matrix. And the question, why we put it like that is to encourage nations to move higher up, to the higher up. Well, they cannot increase the GDP, but for a particular GDP to have as high as possible sustainable waste management. Okay, let's look now what's happening in the world. You know, I don't show that in this figure, but the total urban solid waste is estimated at about 1.5 billion tons. 1.5 billion tons. Of this, 1/3, like 500 million, is either recycled, composted, or waste to energy. Actually, it's 300 million is recycled, composted, and 200 million is going to waste to energy plants. So the rest goes to the global landfills. And of the global landfills of 1 billion tons, 80% goes to non-regulated, non-sanitary landfills, while 200 million tons goes to sanitary landfills. It's an interesting number to remember. 200 million tons to sanitary landfill, 200 million tons to waste to energy. 800 million tons, they go to non-regulated, or at least non-sanitary. You don't capture the methane. And what's the effect? The effect is, or the result, the environmental result, that's out of this 1 billion tons, there's 5% per ton of methane. 50 million tons of methane are generated. However, because there are some sanitary landfills and they recover some of the gas, they recover 6 million tons of methane, which leaves 44 million tons going to the atmosphere. This is equivalent to about 920 million tons of greenhouse gas. It's equivalent to over 3% of the global greenhouse gases. We say that taking care of waste management is the low-hanging fruit on the greenhouse or the climate change tree. And if there are people who don't believe in climate change, most likely they are not in this audience, because the science is clear. We're creating a monster little by little. By the way, this a billion and a half tons that I mentioned of total is projected to double by 2030. This is due to economic development and partly to population growth. So the problem is not going to go away. The problem is going to increase. I mentioned before that landfilling consumes land. It may sound, so what? But for cities, it's a big problem because the cities grow. So let's say you have a city and you put some landfills on the periphery of the cities. Excuse me. Soon enough, people go and build around landfills. I've seen that in the United States, in California. Around the biggest landfills, communities are built. The landfill reaches capacity and that's it. There's nothing you can do. You have to move some other place. See what happens in Beijing. Beijing is literally surrounded by 600 landfills. This is from a movie, a famous movie that I can make available to WTRT India anytime you want to show. It's a movie that shows how big the problem is in the mega cities of the world. That's where it's felt more succinctly, more clearly than any other place. Beijing. But the same is, of course, through Mumbai and Beijing and so on. The next slide now, I showed China. I want to show what China is doing. China, although it's very low, you know, if you remember the matrix, I mean the gross domestic, the GDP per capita of China is higher than India, but it's lower than a lot of other countries. But China decided they cannot afford landfilling, relying on landfilling anymore for the long run. And what they've done, through various means, the government has helped the waste-to-energy industry. You can see it's clear in this graph. From in 2002, 2001, there's from less than 20 plants to 103 plants in 2011. A tremendous growth in China. China is becoming a leader in the application of waste to energy, and I predict sooner rather than later, the same thing will happen in India also, because there are places in India where the GDP is much higher than the average GDP. The average GDP of China is lowered because there's high rural population. But in the cities of China and in the cities of India, there's a lot of money. The GDP is higher. And that's where, of course, the problem is. And that's where the plants, the 104 plants, are being built in the cities. And in the most prosperous cities, more prosperous, more waste-to-energy plants. Now, how does China do that? I'm not going to go through this in detail, but this is from a recent thesis of one of my graduate students who examined in detail the policies that encourage waste-to-energy and the economics, how the economics. But it's interesting that the government has not put money into that. They have helped by means of policies and laws, regulations, to encourage other people, whether Chinese or foreigners, to invest. And you can see this. You can study this. Those of you interested in policy, I mean, you can see on the top there, for instance, they provide $30 per megawatt hour over the price of fossil fuel electricity. In other words, if it costs $100 per megawatt hour to buy megawatt hour from a coal-fired power plant, it will cost you, because the grid or the utility, $130. So right away, you have a $30 premium that somebody has to pay, which helps to build these waste-to-energy plants. And then you can see all these other laws. I think some of these laws can easily be well, I say if you look at this slide, the slide speaks for itself. That one of the measures that the Chinese government has taken to help waste to energy capacity increase, $30 per megawatt hour premium over the price of electricity and fossil fuels. And there are other means there, you can see all of them. And I said that some of these means, the different form, could apply to different states or to the nation as a whole. The other thing is that capital investment in China is very low. It's only $200 per ton, while in America it's $600 to $700. And this is partly because of lower labor. But building such plants, because it gives work to people. Next slide. In closing this presentation, I just want to talk about some highlights of what is called the Global WTRT Council. You might have heard something about WTRT, Waste, Energy, Research and Technology. We have a name, but we're not concerned only with waste to energy. Just as my talk showed, we're concerned with all means of waste management. It just happens waste to energy is one where technology is involved and where research is required. So, the Global WTRT Council was formed in December 2011 because by then we had several nations, several national groups. And by now, it consists of 13 national organizations, including China and India, the biggest nations in the world. Right now, recently, just took a trip to Accra, Ghana, and there's a possibility that the 14th nation will be Ghana, a nation that wants to develop WTRT West Africa. Now, I'd like to salute, to really congratulate the newly formed organization of WTRT India. It was started in 2012. It was co-founded by Niri, the great help of Dr. Rakesh Kumar, and by the Earth Engineering Center, and helped put together the New Delhi workshop where you are now, and the mobile workshop that unfortunately for circumstances beyond my control, I missed. Our special thanks from the GWC, from Global WTRT Council, go to Sunil Kumar of Niri and Rajesh Tanepu of ITSI. To get good things done, you need good people, and we have them there. But we hope that India and government, and I mean all from federal government, from the national government, state government, to municipal government, will continue, will support the India in its efforts to advance waste management in India. What we bring, amongst other things, is the knowledge of several nations. Maybe some of them are participating in this meeting. And some other highlights of what we've done. Professor Marco Castaldi, one of my colleagues, he just authored a textbook on waste-to-energy technology. It will be used in waste-to-energy courses at City College of New York and Columbia University this year. And we hope other universities start teaching that technology. I was privileged to edit a waste-to-energy volume in an 18-volume encyclopedia of sustainability just published. There you will find the best of essays. One of them is by one of the people friends who was supposed to come, but he sent a colleague at this meeting. And also, I was honored to be author. I would be author of the waste to energy section and the landfill gas section in the International Panel for Climate Change, the fifth assessment report, which will be published in a year. And there you will find a very succinct summary again of the knowledge. And other things we've done with the 1 week intensive course on sustainable waste management in Athens, June 2012. It was attended by some people from Azerbaijan, and next year, this term, we have it in Baku, because Baku is building a waste energy plant, and we're going to have any of you who are interested in attending and participating, please, June 2013. And with this, I will open the floor on we also, of course, doing a national study as we have done this for years, trying to find out what is the generation disposition in the US. And you can find a lot of things, information in the web pages of WTRT India and WTRT US and other national pages. Thank you very much, and I open the floor for questions. Ranjit can help me with that. Thank you very much. Yes, of course. You can repeat the question.
Can you hear me?
Yes.
I have developed a pot in which you dump your organic waste and grow plants simultaneously from day one. There is no necessary for you to wait for composting. It is a new technology, and I have also applied for US patent. My invention has been accepted by PCT. This will help us to grow food. It gives you oxygen. It will also cut down CO2. Can you help us for USA? I can send details by email.
Yeah, I got the question, and even deal with you can explain what how much we cannot do,
Yeah, Professor, it's a request for help, so I asked him to contact you via email. Is that all right?
Now, I'll speak to you, Ranjit, also.
Yeah.
Thank you very much. I want to say that any effort and any technology that helps in a small or big way to divert waste from landfills is most welcome, should be encouraged. It has to be economic and to be environmentally sound.
Professor Themelis, good morning. I have a question, and you brought out great global perspective. I noticed one very important point that you mentioned in your presentation: composting of yard waste. And food waste is not going to the compost plant. However, here we don't have many yards on the individual houses as you have it in the US. And we are expecting our food waste, which is in plenty, to go to the compost plant. Now, this is a predicament. In the US, when we talk about composting, we are talking about yard waste composting. Whereas in here, we are expecting our food waste at different stages of putrefaction to get us quality compost. So it will be great to hear from you why focus on whether it is worth focusing on the food waste. Thank you very much.
A good question. You know, when I spoke, I was to say that citizens who have yards or have trees, I appreciate, especially in the big cities, not much of that, but food waste are very difficult. It's a very difficult thing to compost in a large quantity. If it is a small quantity, you know, my home, I work in New York, but my home is in Cape Cod, Massachusetts, and I have a place behind the house where I can take the food waste and I put it there, and there's no problem whatsoever. But if you put food waste in a windrow, let's say the same windrow like you would use for green waste, called park waste, tree waste, then you're going to have a problem, because some of the reactions will be aerobic and some will be anaerobic. And if it's anaerobic, it will generate mercaptans, sulfur-containing compounds, which are very odorous, very smelly, and present a big problem. So the only way you can do food waste in a windrow is by, if you have enough green waste, you can mix them up. If you have, let's say, 70% green waste and 30% food waste, mix them up, and then use a very special composting system, which is air pipes on the floor covered underneath. They push air through, and you cover this thing.
For voice, yeah, I think that's happening again. Dr. Rakesh, do you want to start another session there, because this is like really getting delayed because of the technical difficulties? Yeah? Yeah, we should thank him. Yeah. So maybe we can thank him as we start the other session.
I think in the meantime we can start the next session, because if it takes time, we'll lose a lot of time in this case. So may I request the next session, please, sir. There are a few thoughts which I thought of asking him. We also had initially discussed when we were talking about waste to energy per se as a concept. It was not that we want to burn anything and everything which is not combustible. And as a group, last brainstorming session that we had in Mumbai, it was kind of agreed that it is a wise thing, and I would say also technically it would be a very prudent thing to burn what is combustible and do biodegradation of the material which is biodegradable. What happens is when we are combusting, or which we are trying to burn anything which has got high calorific value, you are likely to have more energy coming out of it. So that's what makes scientific sense. There are places in the US and many other places where they have done mass burn, but that mass burn is, we should realize that there they have a biodegradable component of 15-20%. Here we get 50 to 60%. So the terminology is actually changed from country to country, and therefore our sensitivity towards what should go in what stream is very important to define, and that's why we are sitting as a group here to decide what is right for our country. So we need to get all that information in place and look at our economics of small cities, as we discussed yesterday also, smaller cities, smallest city and big city. So there are places where we really have concern about land, and there are other places where we have concern about something else. So just initial remark from my side. Sir, still there? To your cooperation and interaction in future.